My name is Ben Wild. I'm a community and regional planning student here at UNM, and so Professor Moises Gonzalez and I have been working on a project that we're calling the Solar Thermal Greenhouse. It's based in the South Valley, and we've been working on it for the past year or so. Where's the timer? Okay. And so the central problem that we're trying to address is whether or not we can design and build a low-cost, effective, and sustainable method to increase the growing season for farmers here in the South Valley. That's the basic issue that we're trying to solve at the moment. And so before we do that, it's important to address why we feel that that's important. And so I'm sure most of you can answer that as well, or better than I can. But in my opinion, local agriculture can serve as an economic development tool. It can serve to increase public health. There are positive ecological benefits that have been proven to be derived from that. And the question becomes, as architects and planners, the question then is, how can we help? Well, what is our role in this whole endeavor? And basically, in my opinion, it's technical innovation. We can find ways to increase agricultural production through technical innovation, and that's our role in this process. So essentially, our hypothesis is that the adoption of solar technology will successfully extend the growing season. A longer growing season means increased revenue for farmers in the region, and increased revenue will allow them to compete more successfully in our global market and lead to a more robust local food network. So when I began this project, I went through a fairly extensive literature review, and I found there were two major things that I found that kind of helped inform the design that I came up with. So one was that thermal mass is really important, and the other is that radiant heating has been used successfully to grow tomatoes in indoor environments in the wintertime. This led to my basic design concept. I'm in a room full of architects. I apologize about the rendering. It's not my strong suit, but basically we've adopted the common structure that's used to grow here. We've incorporated solar thermal hydronic radiant heating. We've incorporated a significant amount of thermal mass, and we've tried to shrink the space that we're trying to keep warm. When we look at the specific details of each component, we've added over 18,000 pounds of water into the system, and what we've done is we've calculated the average temperature fluctuations of the water in the tank to kind of get an idea of how many BTUs this water is putting out for us over a 24-hour period. In addition to that, we've built 32 square foot solar thermal collectors. I based these off of just a simple flat plate collector design, and these were built in the School of Architecture and Planning's fabrication laboratory, and here we were testing them down just right out here. Here they are at the site. We've oriented them due south. They're at a tilt angle of 50 degrees. All of that is to maximize winter production. So the idea here is we're trying to add as much heat to the system as we can for the winter time. And TLC Plumbing helped us get this all done, which is why they're up there. This is not a passive system. This is not a thermosiphon system. We're actively pushing this glycol water mix. We're doing that with a 15-watt DC circulation pump. That's being powered by a 130-watt PV panel that goes through a series of different electronics, and then it's also providing power to a 90 amp hour battery bank. So then we can look at what really is this all doing for us. We're not meeting the energy needs required for year-round production. I've found that it gets cold here. So, you know, that's kind of an issue. And with 6 millimeter thick polyethylene covers, it's frankly not that feasible at the moment. But we've also successfully extended the growing season. With just the thermal mass alone, we had a 300 square foot bed of tomatoes that successfully survived through December. In the larger greenhouse space, we lost our tomatoes in late October. And that's at a cost of $315. This is the kind of our attempt to keep this smaller area warm. The data that you're about to look at in the next slide, the one caveat that I would like to mention with that is that my original intention was to have this raised during the day to allow maximum insulation, then closed at night to try to keep that heat. That hasn't happened. It's kind of one of the difficulties of community-based research, and it's just something that you have to work with. So this data, the important things to note about this, Air and soil temperatures during the night have been kept warmer. However, soil temperatures during the day in the heated space are cooler, and that's because we're not allowing any sun to get into this space because our farmer has been a little bit reluctant to raise that up during the day. An interesting side note about this is I've been playing around with the Fresnel lens. They're actually a lot of fun. And so what we did at a cost of $20, I just set up a simple frame. I focused it onto a piece of steel that goes down into the tank, and we focused our energy onto that. And basically what you can see is that you can increase the amount of heat that these tanks absorb using this simple Fresnel lens. And if we can find an inexpensive way to track a series of these, I think you could really start to see significant amounts of heat being added to the system for a very low cost, which is really exciting, I think. So then moving forward, I'm going to be planting the first week of March. I'm going to incorporate full design modifications. We're going to have the passive solar in addition to the radiant heating. I'm going to turn the switch on. We're going to continue monitoring through the spring, and then I'm going to start to try to do an economic viability assessment to see what our return is on all of this and whether or not farmers should do it, whether it's worth their time. That's basically it. I have a few references. Thank you all very much. What's that? Oh, Michael said I had to have 20 slides, so you're going to have to sit here for another 20 slides. Thanks, guys.